Welcome to all. From today, for few more classes, we are going to cover moment of inertia calculations required for steel structures. That is something I will tell. You should write everything. See, in case of steel structures, we got rolled sections. Ready-made shapes are there. Like, see, I write here. I section, see, this way. I use a color here. Rough sketch, I section or channel section. Then we have angle section, see. Angle sections, T sections. These are ready-made sections. This has gone. Okay. See, these are the sections. Here, this section has come slightly more here. I'll remove part of it. It has become a little bigger here. Okay, now okay. Now, this is called I section or also called as rolled steel joist. Rolled steel joist, RSJ. Okay. This is called channel section. This is called angle section. This is called T section. Okay, just put T sufficient. T section sufficient. These are all the readily available sections rolled to the shapes. For all these, see, suppose an I section comes in a question for moment of inertia. What you do? You divide into two rectangles, upper and lower rectangle, that is flanges, and a web. Here also, you divide into three rectangles, divide two rectangles, divide into two rectangles. But there, it is not that way. See, here, one more thing. See, the edges are not sharp. Some curvature is there. So, if you divide into rectangles and find the area will be slightly lesser than this area. Here, little more area is there. So, if a question comes like this with no details given, you divide. We have done it earlier. You divide into rectangles, but in steel structures, we don't divide. Or even for academic examination also, sometimes such questions are given. But what they will do is, see, they will give this property in the question paper. So, now for all these sections, in IS handbook, see, one is called not IS code, IS handbook, properties are given like dimensions of section, then see, what is the width here, what is the depth here, what is the thickness, everywhere, etc. given. Even for curvature also, what is the radius of the curvature, everything is given there. So, what you do is, in steel structures, we don't divide into parts. When a section in a steel structure, when a rolled section comes in steel structures, what you do is, you consider the entire as one unit. See here, entire as one unit. See right here, this way, single unit. See, like rectangular shape, triangular shape, semicircular or quadrant or circular, you know how to find area and moment of inertia. Here, area and moment of inertia, they will give. It is printed in the handbook. See, IS handbook. Next time I won't tell it. It is called IS handbook. Number I forgot now, IS handbook. But with the permission from IS handbook, it is a thick book, little costlier. What they took permission from IS department, and so many people, they published what is required for students. That is very popularly called steel tables. Not steam table. Steam table comes in mechanical engineering. It is steel tables. Steel table. Usually, 99% people use steel tables. Very few, they use IS handbook. Actually, steel tables, they copied from IS handbook only with the permission. Okay. IS handbook, what they have done is, they found out every property here, and for the complete this RSJ, they will give you area and they will tell where is centroid. if centroid is, see, for I section, they will not give details where is centroid because exactly midpoint. This way also midpoint, this way midpoint. See, for channel, this way is midpoint, but this way is not midpoint. For angle, both way is not midpoint. Here also, see, this way midpoint, that is this way, but this way not midpoint. Whenever symmetry is not there, if symmetry is there, they will not give location of centroid because you observe and locate centroid. But if symmetry is not there about an axis, in the steel IS handbook, they will give location of centroid like X bar or Y bar. See, what we call X bar, Y bar, but they don't call X bar, Y bar, they call it as CXX and CYY. That is, here X centroidal distance of XX axis, centroidal distance of YY axis. Then they give area, also they give you what? All dimensions, required dimensions, then moment of inertia about centroidal axis. Actually, furthermore, they even give section modulus, radius of gyration, etc. That all not our part now here. Our part is how to find moment of inertia for section consisting of rolled sections. See, so many questions you will solve. One I section means you don't require calculation. See, if the cross section is only I section, directly you get it. But if it has got, see, our question, we got I section with a plate. Next question is I section with both side plates. Next I will do two parallelly placed I sections. Then two parallelly placed I section with the plate. Then I will go for something else. I section over the top a channel turned and placed, that is used for gantry girder. Then two I section placed here in between a perpendicular I section, that is sometimes rare case for heavily loaded column. Then two channels placed back to back. Two channels placed back to back. I will put line diagram, see, back to back. Or two channels placed face to face. This is without plate. Sometimes same thing with the plate, with the flange plate. Then two angles placed side by side. See, this way. In between gusset plate will be there. Don't bother. For you it is a gap. Two angle placed this way. Sometimes, see, this is for roof trusses they are using. Sometimes for columns, four angles, see, this way, at the four corners. These are all very popular for steel structures. So, academic point of view, either for examination of engineering examination or competitive examination, and even for those who are studying steel structures. So, what I will do is, I will explain how to find moment of inertia for cross sections used in steel structures. Sometimes it can be for beam, sometimes it can be for a column, sometimes it can be for a gantry girder. That you don't bother. For us, I will write, see, I written here, for a beam, cross section of a beam. This beam is not required for you. Our section required for us. But I wrote beam because this is popularly used for beam. Okay. Now, all this part we will cover now. Some 4-5 classes may be required to completely cover. Today I will do, see, this today is part 1. I will put part 1 here. Today's class will be part 1. Part 1. This part 1, part 2, part 3 continue. This part is not that part. See, you can see one more there, part something, part 3. That is moment of inertia. This is sub part. Part A I will put. Okay, part A, etc. Part A. Part A, part B, part C will be there for moment of inertia for cross sections where RSJs are given, where road sections are used, and for every road section in the class, properties will be given. Remember, I won't tell again and again. Somebody will ask, sir, how you got it? These properties are obtained from IS handbook. So, now I will tell what to do. Start. First, I will go for question 87. I will continue the same question number. Last class you did 86, or you can do one thing. You can write for moment of inertia calculation question 87, and moment of inertia question is 1. Okay. The cross section of a beam consists of RSJ, ISMB 400, don't bother, it is given in that way. With a flange plate 250 by 16 on one flange as shown. See, this is a line diagram. Actually, section is not that way. See, this I section, I am going to put the section next. This is called line diagram, shape. Okay, here. Now, properties of RSJ. See, all these properties, remember, make a note. Next time I won't tell. Obtained from IS handbook or steel tables. Next time I won't write. Actually, in examination, it is allowed. You can use it. But if the same question comes in engineering mechanics, then see, in actually questions in steel, they won't give property. Why? They will tell only ISMB 400. They will tell you refer the steel table. But if the engineering mechanics class, you can't refer a steel table. I am giving properties here. Okay. Now, one by one I will tell. First, come to see in the question you can see RSJ. I will explain every section. I will explain at that time. Today's class you require RSJ. RSJ means rolled steel joist. That is actually I section. See, for I section, see, this is called breadth BF. BF is called, you should write in, see, what I dictate you should write. If you are interested, what all I am telling, you should write it. BF stands for breadth or width of flange. This is TF, stands for thickness of flange. See here, both are equal. TW means thickness of web. You can make a small note here. See, this is called flange. This also is called flange, upper flange, lower flange. This is called web. Okay, then this is XX axis. As per IS handbook will always place like this. Sometime I section may be turned. If you turned, you will do it later. Okay. This is called XX. But recently, this XX, they changed to ZZ. But in the new IS code, they changed to ZZ based on software. But IS handbook, it is printed as XX. One fine day, they will change it to ZZ. Then do one thing. Wherever I wrote XX, you take it as ZZ. What is there? See, ZZYY. There's a reason for it. It's a local axis. Don't worry about those things. This is called XX axis. This is called YY axis. Always horizontal axis parallel to flanges is XX and perpendicular to flanges along the web is YY. And then this is called total depth of section H. You write here, H is total depth of section. And remember, depth of section you can see is not given here because, make a note, the depth of section H is always the number given there. See, there are, see, I sections available are ISLB, ISMB, ISWB, ISHB, etc. are there. That number given, see, 400. That number given 400 is nothing but the depth of section H. It will not be told once again. So, in the property, actually depth also given. I won't give because whatever number is given here, that is nothing but depth of section measured along the web this way, total depth. Now, then in the handbook, you can see what is, see, moment of inertia about XX, I about YY, and also they will tell you what is the total area, complete area, A, symbol is A, small a, area will be given. Now, these values are given considering the curvature solved. See, you can see here, it is not straight, it is not sharp edges. See, curvature is there. They considered it. So now what you have to do is, you have to accept these values. With these values, you have to solve. Once you know the property, remember, make a note here, complete I section you take as 1 unit. It's a new shape for you, like rectangle, you know formula, triangle, you know formula, circle, you know formula, semicircle is known, quadrant is known, I section, you know, not formula, you know the value, not formula, it is known, properties are given. Okay, now my first question, see, properties of RSJ given, actually dimensions are given in millimeters. Area in the handbook is given in centimeter square, but I convert it to millimeter square. How? Multiply by 100. You don't worry about it. And moment of inertia are given in centimeter power 4, but we want millimeter power 4. I will tell my students, you read moment of inertia from the handbook in centimeter power 4, multiply by 10 power 4, write in millimeter power 4. Okay. Now, question is, find moment of inertia about centroidal axis to xx, y. Now, if it is a beam question, you require only I about xx axis, horizontal axis. YY not required, but remember, if it is a column section, you require both XX and YY. And if it is a beam section and if it is laterally unsupported, then you require IYY. So in the class, what I will do, whether I will find always both IXX and IYY. If it is not required, leave it, don't calculate. When you go for practical design, if it is not required, don't calculate. Okay, or examination, if question comes, if they ask, calculate. Okay, now the question is fully ready. Question 87. Today I will do only one question. I decided only one question. Systematic way I will solve this question now. Next time onwards, see, next class I will give same problem. I will tell 2 plates are there. I will tell 1 more plate here. Then for the RSJ, these all I will not explain, or any section. Properties I will give you. And centroid location I will explain when the time comes. Okay, now ready for solving this question. Remember, I want full board to write. So remember, all these values you note down, no, not note down, it is given in the question. Okay, now we start. Now start. First write the neat cross section. See, cross section, all dimensions are in millimeter. See, this is the I section. See, it is this one. Properties are given. Properties of RSJ, I told you, breadth of flange 140, depth of section is H. It is not written there. That number itself is the depth in millimeter. Then the total area 7846 mm square. See, centroid will be here. See, for this one, its centroid will be here. See, this junction, centroid, G. I about XX axis is 20458.4 10 to the power 4, IYY 622.1 10 to the power 4. All these are obtained from IS handbook or steel table. Next time I won't tell. And remember, this is considering the RSJ as one unit. See, when I am not divided into parts, do not divide, because entire compact, see, this way, compact. Okay. Now, last time, when properties are available for a rolled section, like today, I section, later, channel, angle, T section, etc., consider the rolled section as a single unit. See, consider as a single unit, and do not break into parts. You consider the entire I section as a single unit. Okay, now do not break into parts. This I will not tell each and every time now onwards. I have told last time, I am telling, sufficient. See, I told really last time. In future, I won't mention this one. Okay, now I will remove this one. No, warning removed. Okay. Now, some more statement required. Okay. Now write the dimension. See here, 250 by 16 in the question given. A line given. See, actually in the cross section, see, it is given like this. Like this is center line diagram. See, center line. So there is no gap here. The plate will fit. Of course, this should be either bolted or welded. That you worry in steel structures. You can't keep as it is. See, either bolted or it should be welded. That all you worry in the steel structures, not here. See, I think I forgot actually when I gave the question. I think flange plate I have given 250 by 16 most probably. So otherwise I have to stop the recording and check the recording. Okay. By chance if it is not 250 by 16, I remember 216. You change it. In the question you change it. Suppose I written 250 by 20 there, you change the question to 250 by 16. Or in case I given 300 by 20, you change it to 250 by 16. So I don't remember now. See the question. I should have noted down. Usually next time I will make a note. Okay. So imagine in the question, if anything else given, change it to 250 by 16. Okay, see now. This is width of flange. Breadth of flange is 140 mm. So the plate will come outside. Okay, now it is symmetrically placed, understood. This is rectangle. See, I will take this rectangle as part 1. You write here. Now we will divide into 2 parts. 2 part means not I section. Right here, entire cross section, see, entire cross section divide into 2 parts. Divide into 2 parts. First part 1, you take that rectangle. That is that plate. 250 by 16. Your part 2 is entire I section, entire RSJ. RSJ as a single unit. See, when I hatched here, see, I hatched it here. This complete RSJ is 1 unit. Okay, remember. Make a note. Okay, then, this all you are right. Now you have to locate centroidal axis for, see, this is XX axis, YY axis for which one? RSJ. This is, see, these are nothing but what? Moment of inertia about centroidal axis of RSJ. RSJ alone. RSJ alone. This XX is not this XX here. Now we want what? Now we right here. Now we want XX and YY. That is right here. Horizontal centroidal axis. XX. Vertical centroidal axis. YY for entire cross section. Entire cross section. Now always remember, if symmetry is there, draw directly. Now make a note. This is, see, right here. Now, here, cross section has axis of symmetry. Axis of symmetry. That is vertical axis. Vertical. That is YY. So, directly mark YY. Directly mark YY. Therefore, no X bar calculation. See, I told 1000 times for you. If you want to locate the YY axis, you require X bar, not required. Directly here, see, through centroid here, mark here, light line, come down. See, light to center, come down and down, pass to centroid of the I section. For the, this is midpoint, come further down. Ayo, it's shifting. Okay, okay. That's all you can make out. Come down, come down, come down, come down, come down. YY. Okay, right, YY. Distance are not required. If case you want distance here, see, this is not required. Total 250 means how much? 125. This also 125. If you want it. This also 125. If you want it. Oh, this is part 1. Okay, I'll remove that part 1 now. See, this is our part 1. Okay. And here if you want, suppose you want distance, not required here. If you want this distance and this distance here, this width of flange is 140, half of 70, 70. Okay, so YY directly located. But, you write, but here, no axis of symmetry, no horizontal axis of symmetry. No horizontal, see, horizontally symmetry is not there. With respect to horizontal axis, symmetry is not there. Therefore, x-axis, we have to locate. we have to locate. Locate class, therefore y bar required. See, to locate x-axis, you require y bar. We will do y bar from the bottom edge. So let us find y bar from bottom extreme edge AB. Y bar from AB equal to, see, only two parts are there. A1 y1 plus A2 y2 divided by A1 divided by total area, that is A1 plus A2. Okay, now always make a practice. You find the total area. Always make a practice to find total area, because in case of columns and beams, so many times area of cross section required. Therefore, better calculate, not waste of time. Sir, A equal to what? A1 plus A2 equal to, see, first remember equal to A1, area of the rectangle 250 by 16 is A1 plus A2. A2 is what? This complete I section area is there, 7846. 7846, that's all. Therefore, you write here your total area, you write somewhere there only, total area equal to 250 into 16 plus 7846. 11846 mm square. 11846 mm square. This is total area. I use that. See, 11846. 11846 mm square is the total area. Calculate always. Make a practice, because in column chapter you require area also. Anybody who can find moment of inertia, they can find area. Okay, now start. Y bar from AB equal to, first, area of this rectangle 250 by 16. One more thing now, see, this is 16. This total depth is, here see, the depth of section H is 400. So this is 400. 400. Then from the topmost edge to bottommost edge will be 400 plus 16 is 416. Make a note. Okay, now A1, 250 into 16 is A1 into Y1. Its centroid from bottom is 400 plus 16 by 2. 400 plus 16 by 2. You can write, or you can make a note here if you want. Or, see, total 416, or 416 minus 16 by 2. Both are same. Your choice. Okay. Plus A2. A2 is the complete I section, its area. It is there. This I told you how many times I have to tell, complete I section as a one unit. See, one compact unit. 7846 is the area. Into its centroid from here. This is exactly midpoint. See, if you can write here, if this is x-axis, see, this distance and this distance, you can make a note here, it is h, means it is h by 2 and h by 2, because symmetrical. So, into from here to centroid is 400 by 2. Into 400 by 2. Complete answer. Okay, this I will remove now. Okay. Divided by total area, we got 11846 is the total area. You get y bar from bottom. Anyone do it, millimeter. Answer will come 250 into 16 into E bracket 400 plus 8 plus 7846 into 200 divided by 11846. 148.675. 250 into 16 into bracket 400 plus 8 plus 7846 into 200 divided by 11846. Huh? What is calculating doing? It is playing with me. 250 into 16 into 400 plus 16 by 2 or plus 7846 into 200 divided by 11846. 270. What is happening? Something wrong in the calc because I got some other. Correct. 270. Yes, I got the answer there. I checked it. I'm getting wrong. I'm doing from there. I did from top edge. Okay. 270.235. Okay, no problem. I made a note there. 270 red color I use equal to 270 point. I use my own value. 270.235. Actually, more numbers are there sufficient. 235 millimeter. Now make a note. Go back and locate x-axis. This I will remove. Locate x-axis. How? See, from here to centroid G2 is half of 400 is 200. But here to extreme up edge, bottom edge is 400. So above this point, below, how much more? 270. This is 200. See? Correct? Huh? This is 200. I think little down, not that much. Okay, no problem. Because this is 270 more. Okay. That is not a problem. See, okay. This is your x-axis. From the bottom edge, you got up to here. How much? 270.235 millimeter. All in millimeter. Now do one thing. Therefore, from the topmost edge to here will be how much? It will be, calculate, total 416. 416 minus 270.235 is 145.765. This is 145.765. See, this question, XX symmetry is not there. Next time when I do a question, there is one plate here and also one more plate here. At that time, XX also symmetrical. So no location of centroid. Next time I will tell. Okay. Actually, I made a note somewhere there. I got 145.765. I was wondering how it is 270. Because I calculate from the top edge. I got, you cannot see it. It is there. I safety. I found from top edge. I got 145.765. Correct. Okay. Now, fully over. Okay. Next step. See. Next step is very important. Calculation of moment of inertia about centroidal axis. That is I about xx and I about yy. Right here. First one thing. Before this, I will repeat now. Before you start calculating, see, every class I will not tell because actually it is already told thousands of times. Still, one question I will explain everything. First write. Okay, this much statement you write there, then write. We have, next time I won't write. See, we have color change. Okay, we have from parallel axis theorem, I about any axis equal to, it is told thousands of times. Nobody should tell now, sir, what is this not clear. See, equal to your, see, green color, Ig plus area into h square. What is Ig? What is area? What is h? These are all explained infinite number of times so far. So today I will not explain. Still briefly, moment of inertia about an axis passing through its own centroid parallel to required axis. Area of the part considered or component considered. Perpendicular distance from centroid of the component to required axis. Horizontal axis means, someone will tell this way, vertical distance square vertical axis means horizontal distance square. Okay. Really last time. I write here now. Really last time, because really last time. If it is offline class, so many students will be there, they will do this way. Abba, how many times he is telling same thing again and again, but nobody got the courage to in front of me. If somebody will tell me in front of me, sir, this you are telling so many times, sir. What? You are expert then? No, sir, I am not expert. Then keep quiet. I will tell whatever number of times I want. My purpose is to give education. If you know already, keep quiet. But nobody, so far, nobody told me when I told repeatedly, sir, how many times like that. Okay, start. Now start first. Space is sufficient. I about x. Directly see here. First I will do for, see, rectangle. I about its own centroidal axis, see, parallel to x-axis. 250 into 16 cube by 12. 250 into 16 cube divided by 12 is Ig plus area. 250 into 16 is the area into, see, into from centroid G1 to xx, see, this distance square. This distance is 145.765 minus half of 16. That is to be whole square. Close it. See, this is for 1. Make a note here. This is for 1. Then plus. I hope space is there. Okay. Plus. Little down I will come. Okay, start. I about xx for this complete I section. What you do? First come to centroid of the I section. Here, see, its own centroid. This is the centroid for complete I section as one unit. Axis passing through centroid and parallel to x-axis is this axis. See, this axis. I about its own axis. I about this axis is, see here, I about this axis. That Ig is nothing but your Ixx. How much it is? 20458. 20458.4 10 to the power 4 is Ig plus area is 7846. 7846 area multiplied by from centroid of the I section to xx, see, from centroid here, this distance square, that is 270.235 minus, see, we want this distance square, this full distance minus from here to centroid is exactly h by 2, h is 400, see, this h is 400, see here, only h, this h is 400, be careful, minus 400 by 2 whole square, calculate, close the bracket. This is for 2, see, this everything is for 2, okay, get the answer. Now, calculate and get the answer. Answer I am not writing, 10 to the power 6 millimeter power 4. Calculate it. Now, next, I will rub by xx now. I want I by y. Any space problem is there? Can I write below? I think I cannot write below. Oh, I can write below. There is space. Okay. I can write below. Okay. So everything will be intact. To save the time, you write the answer here, anywhere. You write whatever you get equal to, write the answer, preferably in something, write the answer. 10 to the power 6, your choice. Answer will come in millimeter power 4. Okay. Now, I about yy. See, very slowly I am explaining. You can see here, I about yy. This you require if this is a cross section of a column or if it is laterally unrestrained beam. Why worry in steel structures? Okay, start. Come to rectangle. I about, see, centroid is here, about its own centroidal axis. This axis is 16 into 250 cube by 12. 16 into 250 cube by 12 is IG plus area 16 into 250 or 250 into 16, whatever you want, into, see, into from centroid G1 to YY perpendicular square. Oh, centroid G1, see, G1 and G2 are lying outside XX. So with respect to XX, G1, G2 are outside, but with respect to YY, G1 lies in YY, therefore 0 square. This is told many times. Okay. This is for 1, see, this everything is for 1 plus for 2. Come to this I section. We want I about YY. Come to centroid. Axis passing to centroid parallel to YY is this axis. That axis is nothing but this axis. See, this axis. I about that axis is there. 622.1 10 to the power 4. 622.1 10 to the power 4 is IG. IG plus area is 7846 is the area into distance square from centroid G2 to YO. Centroid G2 also lies in YY, therefore 0 square over. Close the bracket. Calculate the answer, preferably some 10 to the power 6 millimeter power 4. Okay. Now, if it is a beam question, next you have to find the section modulus. That all comes in the steel structures, not here. If it is a column problem, next you have to find radius of gyration. R about XX and R about YY. R about XX equal to IXX divided by total area root. You have to take square root. R about YY is square root of I about YY by area. Once you get those two for a column, then if the effective length is same with respect to both the principal axes, then you have to consider least R and find a term called slenderness ratio, that is L effective by least R. By chance, if it has got different effective length, you calculate effective length with respect to XX axis by RXX, one slenderness ratio, effective length with respect to YY axis divided by RYY, one more slenderness ratio, and then you have to enter IS 800, steel IS code 800, and find for that slenderness ratio what is the allowed compressive stress, that is called FC, no, the symbol I forgot, sigma AC, not sigma AC, the symbol is forgotten, FCD. It is new, earlier code sigma AC, new code it is FCD. You find FCD, then you find multiply by area and find axial load, if only axial load. If axial load with bending is there, lot of complications are there. All those we will consider steel structures. In this chapter I told just for those who are interested in steel structures. In this class, from tomorrow onwards, next class onwards, I won't tell all those things. I will concentrate on how to find I about XX and I about YY and total area when the given cross section consists of rolled sections. Of course, rectangles can be there sometimes, plates. If plate is there, it's a rectangle. So when rolled section like I sections, then channel sections, angles, T's, plenty of questions I will solve. I will see that when I take steel structures class, at that time I will tell the students, moment of inertia, I will not explain much here. I only took engineering mechanics class. Go back to my engineering mechanics class, search moment of inertia, part 3, there I will tell something is there, moment of inertia calculation for steel structures, I written there, or I were dedicated to steel structure, some word I will use, dedication, okay. These are all dedicated to steel structure, good word, dedication, is dedicated to steel structures. Therefore, you refer there and completely understand and come back to the class. Don't expect me to tell once again parallax theorem, etc. Okay, that's all. This class I am closing now. Next time, same I section. See, I am putting a plate here. I will put a plate here. Same identical plate. What is that plate? Same plate here. But I will do one thing. I section I may change. I will give some other I section. Not ISNB 400, some other I section. Then see what happens is, see, the XX axis will correctly come here. So then this will become not 416, 400 plus 16 plus 16, 432. This is 432. This both will be directly how much? 216, 216. Next class, 216. Therefore, next class question, that is question number, second question of the series, or question number, I forgot the question number, no? 88, I think. Today 87. 88. There is no need of locating XXYY. Directly you can do it. That is advantage. Then when you go to further question, in some questions you have to locate centroid by either X bar or Y bar. But so many questions, centroid is directly obtained, symmetry is there, but moment of inertia part is important. Okay. Study thoroughly. Next class we will continue our dedication to steel. Thank you.